Look, what do you got for us today?
This is the second episode of biasing, how to bias an amplifier. The first episode, I taught everybody how to bias with a bias meter, which is a perfectly good method of biasing. Uh, this method teaches you how to bias without a bias meter. And I'm showing you two ways. These are both safe ways, safe for your equipment and generally safe for you, as long as you're not touching inside of the amplifier. So first I'm going to show you, a couple of schematics. So I'm going to share my screen. Alrighty, so here is one of my amplifiers, and this is a set of power tubes right here where my mouse is circling. And the cathode here has two resistors on it, one resistor for each power tube. It's a 1 ohm resistor, and that goes to ground. So in the last episode, I talked about if a power tube was the cathode was attached to a resistor and a capacitor, then that tube was cathode biased and does not have an adjustable bias. This has a resistor, but no capacitor, and the resistor is just 1 ohm. Does not make the amp cathode bias. It is still fixed bias. And if you look down here where my mouse is circling, this is the bias circuit. You get a bias voltage off the power transformer. It comes into these couple dropping resistors and such, and then you get a negative bias voltage that goes up into right here. And that's where you get your bias from. So this is still a fixed bias amp. It just has a 1 ohm resistor attached to the cathode. And the thing that makes this easy is you can attach your DC voltmeter and get a get a measurement. If you measure on either side of one resistor, that will give you what your amplifier is biased at. It's very cheap. It's cheap, and it's good to implement in new amplifier designs. I wouldn't do this on vintage amplifiers because we're not trying to modify them, but it will be a good option for something that maybe has been modified beyond collectability. And this way, every time you open the amplifier, you can measure across those 2 ohms. That's why I implemented it in my design. It's just an easy way to bias with no special equipment, and you get a quick, accurate reading. So I'm going to stop the screen share and then switch over to my phone. And do you have to do that? Switch over to my phone there, Ian?
I can do that, yeah. Let's see here.
All right. Did you switch? There you go. Perfect.
Go ahead and throw that. It's probably going to be better if you flip that just so that it's in landscape mode.
All right. Flip it to be in landscape mode. Do you know how to flip it?
Yeah, if you just flip the phone, you might be in rotation lock or something like that, which I don't think it's worth getting into it. But if it doesn't flip on its own, then we'll just deal with it as is. Yeah, that's fine. We'll make do.
All right, we'll have to practice that for next time.
What kind of phone do you have?
An iPhone.
So is there an orientation lock? Where is that? Yeah, I gotta take this really quick. Go ahead and keep going. I'm gonna mute.
Okay. All right, sounds good. All right, so here's the amplifier.
This is Ian.
Why don't you mute, Ian?
I'm well.
Ian, mute. All right, so I'm going to turn the amplifier on, and I'm going to read some voltages here. So sorry, hang in there with me real quick. All right. So I got my meter, got it set for DC. And the first thing we need to figure out is what we need our amplifier to be biased at. And to do that, we use the same calculator that I showed in last week's video, and I'll show it again later today. I'm going to measure my plate voltage with my meter set to DC at 444 volts. Checking to make sure that my AC is set for the average wall voltage, which is about 120. So 435. And then I'm going to put that into the calculator and I'll get my bias reading, which my bias reading is about 40 milliamps. So this is actually just giving you the DC resistance. I could go into greater detail, but for the sake of complexity, I think that's all you need to know. So I'm just measuring across this resistor, which is this pin 8. Pin 8 is the cathode, and then this is a 1 ohm resistor, and I'm measuring across it, and it gives me a very small voltage of 0.039 volts. If your meter has a millivolt, you could switch it to millivolts, which is, it just gives you 39 millivolts, which is the same as the DC. So you also could just take your negative and put it anywhere to ground and measure on pin 8, but it has to have a 1 ohm resistor, the cathode to ground, and that's how you would measure it. Now, my bias pot is right here, so a plastic one. I could adjust this and see now it's reading about 48. Here, let me switch my meter to ground. So,
Luke, can you hear me?
yes, I can hear you.
Oh, that's weird. You should not be able to hear me, but
I can hear you now. You muted yourself for the phone call, but now I hear you.
I did, but this should be going through my mic and it's just not. I don't know what's going on. It's picking up the internal mic of the oh, I see.
All right, so there's a, so now you can see the, I can adjust the voltage with this bias pot here. So I'm just measuring from pin 8 to ground, and that is, and what that is doing is measuring across that resistor, and do it for both tubes to make sure that they are equal, and these are pretty well matched. If you get out of 10-20%, you're going to think about swapping tubes, or maybe you don't have a set of matched tubes. So I got 39 and 39. That's dead on matched. So that is a good set of tubes, and they are biased properly. And that's all there is to biasing that. You can leave this in circuit all the time. This is probably the easiest, best, safest way to set up your amp to bias. But if your amplifier does not have that, then, or if it's a PCB amp, then you're going to have problems. You're going to have difficulties implementing this circuit. So now I'll show you another way. I'm going to go back to the computer so I can show a couple things.
So I'm going to take the spotlight off of this.
Yep, thanks. So I know it's back and forth a lot, but
that's all right, man.
All right, so I'm gonna do another screen share. All righty, so let's look at, this is a basement. Turn this amp off so I don't forget about it. This is basement. This is the one we've been working on. This is reminiscent of a lot of other circuits, Vibrolux Twin Reverb, any of those bigger Fender amps. So so here's the layout, and here's the schematic, of course, and I always like to keep showing you guys the schematic. So again, here is your cathode, and to review what we just did, if you wanted to, you could disconnect the cathode straight from ground and put a 1 ohm resistor between pin 8 and ground on this one, and then you could bias your amplifier just as I did my amplifier just now. Here's the bias circuit, just like mine, and then it goes up here to the in between these 220K resistors. So just to kind of beat it in your head, that's what the bias circuit looks like, and this is what a fixed bias amplifier looks like. But say this is a vintage amplifier and I don't want to implement those 1 ohm resistors. Here's another good way to do it. It involves a little bit of math, but luckily there is a calculator. I am not great with doing algebra, so I always use calculators. Millennial, and that's just what I do. So if you can do all that stuff in your head, more power to you, but I cannot. Let's see. So switch to, I made this is going to sound confusing if I'm just saying it outright, but in conjunction with this video, you should be able to follow along. So first, what we're going to do is measure the resistance between the center tap of the output transformer and the primary lead. And that is the center tap of the output transformer is going to be right here. This is the output transformer. And this is a primary and this is a primary. This is the primary side of the output transformer. So this primary goes to the plate. This primary goes to that plate. And then the center, which is usually a red wire, goes down here to the high tension supply. Big words, but red wire, usually blue wire, usually a brown wire. You're going to measure the resistance with the amplifier off. So red lead to this node, black lead to this node. You're going to get that resistance. You're going to record it. And then you're going to, after you got both resistances of both sides, then you're going to turn the amplifier on and you're going to read the plate voltage. Plate voltage is going to be right here. On this amplifier, it's labeled as 420, but all amplifiers vary a little bit. So just double check that measurement. If it's 410, if it's 430, that'll change your bias reading just ever so slightly. So keep that in mind. So you measure your plate voltage and you get that reading. And then we will put that, this one 1 second. Oh, there we go. Perfect. Here's the bias calculator. I showed you this last time. You get your plate voltage and you input it into the calculator, 420. It's 6L6s. Make sure it's GC. It's for 30 watts, and then you click submit, and then it tells you what your bias point is. Now you want about 70%, 60 or 70%. Any more than 70% is running a little hot, but I like to set it right between 60 and 70. So you got 50 milliamps, and then you have for 70% and 42.8 for 60%. Now we know what our current. Now we know what we want our current to be, and we know what the resistance of the output transformer is. So we can just put this into Ohm's law, and we'll give you a small voltage up here, and that will be the voltage between the center tap of the output transformer and the primary lead. I know this sounds like a bunch of complicated terms, but when you see it in practice, it'll make sense. And once you do it a couple times, it'll be like second nature. So let's just go for sake of clarity. Let's go for 70%, 50 milliamps. This is the current in amps, so we have to do a little bit of a conversion, but all you have to do is move the decimal point a little bit. So 0.050 is the current that we're after. Remember that this is the current we're after, 50 milliamps. So 50 milliamps is 0.050 amps. And the resistance of one side of that transformer. So let's say the blue lead, okay? I pre-measured them. It's 46 ohms. So it's 46 ohms. And then you hit calculate, and it gives you 2.3 volts. Write that number down, and that's going to be the voltage between the center tap of your output transformer and that same lead that you read that resistance on. So I'm going to write off screen, I'm going to write this down. We got 2.3 volts. Check on that plate voltage. And the other one I've pre-measured, and it's 48 ohms. The other one I measured in is 48 ohms. It's not going to be really that much of a difference, but just for clarity, 0.050, it's going to be the same. Your target current is the same. The resistance is 48 ohms. Calculate, you can see that number went up a little bit, like 2.4. 2.4. What's 0.1 volts between friends? Let's switch. So that's how you figure out all of your target voltages. All right. Plate voltage, put it into the calculator, you get your current. And you take your current and you plug it into the calculator, and you take your resistance that you already measured and put it into the calculator. You hit calculate, and then you get that small voltage that you're going to get. Now let's switch back over to my phone.
I'm working on it. I don't know why it moves around so much. Oh, here it is. I might be blind. There we go.
All righty. So all right, so here's that basement meter. We're going to do all of those things that I just said. First, we're going to measure the resistance. And for Fender amplifiers, this red wire that comes out of the same hole. So there's a hole here, and there's a red wire, a blue wire, and a brown wire. The blue and the brown wire go to pin 3 of the power tubes. Brown wire goes to this pin 3, blue wire goes to this pin 3, and then the red wire that comes out of the same hole goes onto the board here. This is your center tap. There's a bunch of voltage here. It's the same voltage that will be on the plates. This is, according to the schematic, it was 420. So you'll get 420 here, you'll get 420 on the output tubes. All right, but we're going to measure the resistance. So we're going to set our meter for resistance. Measure here. Got 49.5. Thought it was 48. Show 49.5. 46. All right. 1 ohm isn't a big deal difference. So we're going to stay with our measurements. So we have that. We're going to record it. Now we're going to plug in our amplifier. And make sure you got it plugged into a load. Fire's on. Switch our meter to DC. We're going to measure the plate voltage. So measure that, stick it on the plate, and then I know there's a glare on the screen. Got 430 volts, 435 volts, 430. About the same. There's always there could be a little fluctuation when you're switching from one to the other, but 1 volt, a couple volts, not a big deal. If there's a big swing, then there might be a problem with the amplifier. If there's like 20 volts on one plate and 20 less volts on the other plate, there might be a problem. But 1 or 2 volts is normal variance. All right, so we already got all of our measurements and we put them into the calculator. I wrote them all down. Our target voltage for both tubes is about 2.4 volts. So I'm going to connect one lead to the center tap, which is that red wire, one lead to that blue wire, and I should get a very small voltage reading. I got 2.18. and up 2. So I'm just a little bit low. So I'm going to adjust the voltages, and I'm actually going to. So I got one extra hand here. Screwdriver. Sorry. All right, so we got 2 volts. I'm just going to adjust this bias pot to get that 2.3. It's 2.2, 0.3. Check the other one. At 2.5. So that means these might be a little bit out of balance, but remember that resistance is also comes into play. A couple ohms difference will change that. You just input it into the calculator to get your absolute perfect voltage. I'm just going to bias this a little bit under anyway. I'm going to bias it at 2.2, which is going to set me somewhere between that 70 and 60%. So just to double check everything, we can write all this down. 2.2 on that one. 2 on that one. We'll bump this up. 2.1 and see where we're at over here. 2.1, almost 2.3. All right. So I'm going to write this down, and we're going to put it back into the calculator and see where we're at. Just to reiterate everything. So I already forgot that quick. Got 2. And it's just the voltage is moving around because I'm not touching the contact correctly. 2.3. First one. 2.1 on the second one. I had 49 ohms on this one, and I had about 47 ohms on that one. All right, so we turn all this stuff off. And then switch back to the computer. Ian.
Be good to go.
Alrighty, and we're going to put all of these numbers back into the computer here. So, but this time we're going to do a little bit backwards here. We're going to remove the current, and we're going to reset everything. But instead of putting the current in the resistance, we're going to put what our voltage is, and we're going to put what our resistance is, and then see where the current ends up. So we had a voltage on the first tube of 2.3. Oh no, sorry, 2.3, which was our target anyway. And then the resistance was 49. I hit calculate, and a current of 46 milliamps here. And you know, that's right within the bias spec. So bias spec again is between basically 42 and 50. 46 is that sweet spot. That's what I want. That's where I want this amp to live. We're gonna do, and now we'll do that other tube, which the other tube we had 2.1, and then the resistance on that tube was 47, and we're getting 44. That's we're 2 milliamps out of balance with each other. I'm perfectly happy with that. What you don't want to see is when you start getting around 10%. So like we got 44 here, 10%, minus 10% would be around like 40, closer to like 39. So if I got 39 if I have 39 on the other tube, I would start to consider that these tubes are out of balance. And if they were worn tubes, if these are tubes that had been in for a long time, I'd start to consider replacing them based on what the customer is trying to get out of the amp. But even still, I tend to go about 20% out of balance. 20% is like my limit. If it's 10%, I'll have a conversation with the customer. And if it's over 20% of a mismatch, I will extremely recommend replacing those power tubes for a matched set. Let's see. I think that's about it for, you know, they're that's kind of my go-to method of getting a voltage. I don't have to mess with the bias meter. The less you take the tubes in and out, the better. So this, you can do all that biasing without taking the tubes in and out. You don't have to worry about blowing anything up. You can measure, you can play and measure and play and measure. With the bias meter, you have to take the meter out every time you want to play it, and that can become problematic. So that's why I prefer these two methods. I definitely prefer the 1M method, but that's just not possible with all vintage amps. I'm not soldering the cathode in and out for those vintage amps. New amps, and for amps that it doesn't matter if they're modified a little bit, popping that 1M resistor in is a good option. It's also, there's a way that it's called the shunt transformer method, where you actually measure the current going across the center tap for the output transformer and the plate of the tube, just the way we measured that small DC voltage reading. But with the current method, you're actually putting all of that voltage, all of that current into your meter. So if you have one side hooked up to the center tap of that output transformer, and with your other lead, you touch yourself with it, you'll get that full 440 volts of voltage right to you. With the DC reading, you don't get that. You don't get that voltage through the meter that way. So it's safer in that respect. Also, if you, with the current shunt method, when you're measuring the actual current, if you touch the center tap and then you touch ground, you'll fry your meter, or you'll, at a bare minimum, you'll blow a fuse in your meter. And it's just, there's too many, it's too easy to slip with your meter and touch something you're not supposed to. It just becomes a pain in the butt. It is simple because you just have to touch two places in the amplifier. But if you slip or if you touch yourself, it's not good. But I did not show that method. I just showed the resistor method, the 1M resistor attached to cathode, and I taught the Ohm's law method, basically doing a bunch of calculations. The downfall of the calculation method is you got to do a bunch of calculations. It's a pain in the butt going back and forth. That's why the resistor method is straightforward. I think that's about it for this method. I think I covered a bunch of different ways to do it. Things you have to look out for are the way that your pot is set up. But I shared some schematics and layouts to show you the common ways that a bias pot is set up, so you can adjust it for the methods that I've been showing. Yeah, if you guys have any questions about any of the bias stuff, let me know. Might do one more lesson on bias, or I might just start showing different amplifiers and different scenarios that we come up with. I'm going to try to get like a Hot Rod to Build Deluxe and Blues Junior, which are those amps we see all of the time, and then kind of take it on case-by-case basis from there. Unless somebody wants to join me, or if somebody has any questions, I do have some guests that I'm thinking about inviting on, but everybody is always welcome.
Who are the guests?
A couple amplifier builders. I'll run them by you. I think I might try to get Nick Greer on. I might try. I have a couple of techs, one in Detroit, one in California. Anybody you're interested in seeing? Might see
what about, you'd probably be better off asking Nathan if he's got anybody he wants to see. He's into amps more than I am. Nathan, you got anybody you want on for guests?
No. Those
No.
guys sound good.
Those guys sound good. Well, we'll start with those. That sounds good. Hey, do you have anything you want to say about biasing, or you want to ask ask Luke a question or anything?
No, that seemed like it was covered well.
Yeah, I didn't misspeak on anything, did I, Nathan?
No, I don't think so. I think it was good. I don't know if you mentioned it, but like when you go to measure that DC resistance, you'd want to make sure you drain the caps first
Yep.
when you're doing measuring off the transformer.
Yep.
That's the only thing I could think of.
Amp off and cap strain. Yep. Yep. I got a couple new pliers that I'm really a fan of. Just as a quick tip.
Oh yeah.
They're called Nipex.
Look at these. What do those do? They look like snap ring pliers.
So these are called duckbill pliers. And I had a hard time finding. They make different duckbill pliers, but this one helps you straight out bent leads really well. So
Oh,
if you got
cool.
if you have a bent lead like that, you
Uh-huh.
you kind of you straighten it out.
Give it a bit of the duck bill.
Yeah, and there's all you can grab certain components better because it's a super wide jaw. So like, holding a resistor like this is a lot easier. I actually use them way more than I thought.
Who makes those?
Nipex. I mean, a bunch of people make, or a bunch of companies make these duckbill pliers, but I specifically like these ones. The quality of these pliers, I've been using a bunch of cheap pliers for a very long time.
Jeremy's holding up some more Nipex product.
Oh, there you go. Nice.
Jeremy, unmute and talk about these. What do you got?
These are the wire cutters that I use for every string. I think they are the best tool that I own because they got good leverage. They can cut through pretty much, and they cut through a nail
Yeah,
easily.
you could like break into a school to skateboard with one of those, right?
You could definitely cut a chain link fence with this.
Yeah.
They're like $80, but I have yet to see anywhere on the jaws. And then these are the small ones that I use for nylon strings.
Oh, will those cut regular strings, or you run them with regular strings?
I think you'll probably ruin them. I haven't even. I'm like, don't even want to try it.
Close string cutters
the small ones do cut the strings, but they do leave a small mark on the jaws.
No,
Won't do it.
If you're looking for nippers, cutters, Knipex are the ones that are decent.
Steve, I was just wondering about you the other day.
Oh, were you?
Yeah, I was wondering what happened to old Steve.
Yeah, I'm in most Sundays.
Oh, cool.
Just lurking away.
Busy coordinating his lampshade and his pillowcase.
Exactly.
Luke, I feel like we've gotten away from what you're doing. Should
no, that's okay. It's just
anything more on the cutting edge of plying?
These little bent nose pliers.
Yes.
They're skinny. I've gone way too long without using bent nose pliers. I use these all the time, and again, I think these are also Nipex. They're like, I think they're like $30. $30.
I'm guessing Nipex, their flagship model, was probably a pair of nippers, right?
I would, according to the name, I would say.
Whoa. It could be a German thing.
Yeah, Nipex.
If we're doing an Apex ad, these ones with the cone,
Oh yeah,
they're the shit for bending leads too.
yeah.
Focus.
What's the deal with the cone?
They're like two cones that come together,
Yes, sir.
and so you can bend it. You can bend leads around them. You get like a nice curve to the lead.
Okay.
Yeah, you make a nice curve.
Oh, that is nice.
And then if you wanted a big curve, you just go back further on the lead, and it just gets you a perfect little bend. So yeah, but these different, I don't like these. I'm gonna get a better pair. I've realized once I bought a pair of $30 pliers that it's actually worth $30. These I've had like $10 pairs and $15 pairs, and
Mhm.
I just never bought good pliers, and I bought a couple sets or a couple pairs of good pliers, and the tips don't bend. You know, they're really hard for really far out. They come together perfectly. The cheap pliers, you know, you can't see on the video, but the
Yeah.
tips get bent and they don't come together correctly. And when you squeeze stuff, they bend, and you don't realize it until you get a good pair of, I guess it's stainless steel.
Steve says it's actually pronounced Knipex.
Yeah, I think it is Knipex.
All right, there we go.
Knipex.
Knipex? That sounds like a Canadian province.
It's what you get before every wedding when someone's walking around.
All right, well, I guess that's it for this
Can
episode.
I Jesus Christ, Jeremy. You're like a fountain of those things.
I was just thinking of Godfather too.
Huh? All right.
Luke.
Luke, thank you so much, man.
Yep, thanks, and do it again next month. And if anybody's
Yeah.
got anything in the meantime, send it over.
Absolutely.